In video example 2, we don't need to make an assumption about the volume of material that we have. In fact, we're given that very explicitly. And we are given SI units here, so we're going to stick with SI units. So on one side, we'll keep track of volume. On the other side, we'll keep track of mass, not weight. Since we were given grams, we'll stick with grams. And we are told that the total volume of all the phases is equal to 80 cubic centimeters. And all my volumes will be in that. And we'll have our solid phase, our water phase, and our air phase. And we were given some masses here. We were told that the mass of the sample when dry was 159.2 grams. So that's $159.2, and we can calculate the mass of the water as 172.3 grams when wet and minus 159.2 to give us a mass of water equal to 13.1 grams. So we won't have any mass for the air, so now we just got to find the volume of these various phases and we'll be in business. To get the volume of the solid phase, what we'll need to do is recognize that it's 159.2 grams of solid, and if we multiply that by 1 over g times rho, where g is the specific gravity and rho is the mass density, we'll get what we want, and that's equal to 159.2 grams divided by 2.65 times, then there's 1 gram per cubic centimeter, and that gives us the volume in cubic the grams cancel out, so we get our answer in cubic centimeters, and I got an answer of 59.6. Well, I used a couple digits here after the decimal. 59.62 cubic centimeter. So we add that to our diagram. The volume of the solid phase is equal to 59.62 cubic centimeters. Similarly, we need to find the volume of the water. Well, that's an easier calculation, one that you can do in your head. We have 13.1 grams of water, so it's got to be equal to 13.1 cubic centimeters of water. The only thing that leaves us to find then is the volume of the air phase, and we can get that by volume of the air is just going to be equal to 80 minus the sum of 13.1 plus 59.62. I got 7.28 cubic centimeters for the air phase. Now we're ready to just go right to coming up with all the answers to solve this problem. So I'll need some space to do that. I'm recognizing that you can hit rewind if you needed to see any of that again. And I'm just going to give myself a little more room here. And the first thing that we're asked to find is the water content. We can get the water content as the mass of the water, 13.1 grams, divided by the mass of the soil, 159.2 grams. And I got an answer of 0.082 or 8.2%. So I'm going to write my answers over here. Water content is equal to 8.2%. Next, we're asked to calculate the degree of saturation. We can get the degree of saturation, capital S, is equal to the volume of the water divided by the volume of the void, and that's equal to 13.1 cubic centimeters. And for the volume of the void, we just sum up 7.28 and 13.1, and when I did that, I got 20.38 for the volume of the void, air and water together, and I got a degree of saturation equal to 64.3%. Capital S is equal to 64.3%. Now we need to get to our unit weights, and we're asked for the unit weight, which when it doesn't give you anything but, notice it says the unit weight, it means moist, so as it was sampled. So to get that, I'm going to need more space again. I can get the unit weight, which is basically the moist unit weight, so I put a little sub m, which I sometimes use, sometimes don't. When there's no subscript there, you should assume it's the moist or as sampled unit weight. So we found that we had 172.3 grams of material in 80 cubic centimeters of soil, and we now need to calculate that that's equal to 2.154 grams per cubic centimeter. But that's a density, that's not a unit weight. If we want to convert to unit weight, we can just use the conversion factor that we know to be 1 gram per cubic centimeter of water is equal to 9.81 kilonewtons per cubic meter, and all we need to do then basically is multiply. Now with that, our units are in kilonewton per cubic meter, and I got a moist unit weight equal to 21.1 kilonewtons per cubic meter. Next, I need to calculate my Next, I need to calculate my dry unit weight. So, to get the dry unit weight, I would just have 159.2 grams of materials divided by 80 cubic centimeters, and I can just put the conversion directly in here. 9.81 kilonewtons per cubic meter is equal to 1 grams per cubic centimeter, and that gives me a dry unit weight of 19.5 kilonewtons per cubic meter, and I'll write that down up here. Now I have to consider saturated conditions. If saturated, I have 7.28 centimeter cube more water, or 7.28 grams more water. So I can get my saturated unit weight simply from taking 172.3 grams, what it weighs moist, add 7.28 grams of water, divide that by 80 cubic centimeters of sample, and that, remembering that I need my conversion, 1 gram per cubic centimeter will convert to 9.81 kilonewtons per cubic meter, and that will get rid of all my units except the ones I want to be left with, and I got a saturated unit weight of 22.0. And now, with that added to my list of answers, I've solved video example 2.